Section 52 of Gray's Anatomy, Part 4. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Anatomy of the Human Body, Part 4, by Henry Gray. The refracting media. The refracting media are three, viz. Aqueous humour, vitreous body, crystalline lens. The aqueous humour, humour aqueous. The aqueous humour fills the anterior and posterior chambers of the eyeball. It is small in quantity, has an alkaline reaction, and consists mainly of water, less than 1/50 of its weight being solid matter, chiefly chloride of sodium. The vitreous body, corpus vitreum. The vitreous body forms about 4/5 of the bulb of the eye. It fills the concavity of the retina and is hollowed in front, forming a deep concavity, the hyaloid fossa, for the reception of the lens. It is transparent, of the consistence of thin jelly, and is composed of an albuminous fluid enclosed in a delicate transparent membrane, the hyaloid membrane. It has been supposed by Hanover that from its surface numerous thin lamellae are prolonged inward in a radiating matter, forming spaces in which the fluid is contained. In the adult these lamellae cannot be detected even after careful microscopic examinations in the fresh state, but in preparations hardened in weak chromic acid it is possible to make out a distinct lamellation at the periphery of the body. In the centre of the vitreous body, running from the entrance of the optic nerve to the posterior surface of the lens, is a canal, the hyaloid canal, filled with lymph and lined by a prolongation of the hyaloid membrane. This canal, in the embryonic vitreous body, conveyed the arterial hyaloidae from the central artery of the retina to the back of the lens. The fluid from the vitreous body is nearly pure water. It contains, however, some salts and a little albumin. The hyaloid membrane envelops the vitreous body. The portion in front of the oris serrata is thickened by the accession of radial fibres, and is termed the zonula ciliaris, zonule of Zinn. Here it presents a series of radially arranged furrows, in which the ciliary processes are accommodated and to which they adhere, as is shown by the fact that when they are removed some of their pigment remains attached to the zonula. The zonula ciliaris splits into two layers, one of which is thin and lines the hyaloid fossa, the other is named the suspensory ligament of the lens. It is thicker and passes over the ciliary body to be attached to the capsule of the lens a short distance in front of its equator. Scattered and delicate fibres are also attached to the region of the equator itself. This ligament retains the lens in position and is relaxed by the contraction of the meridional fibres of the ciliaris muscle, so that the lens is allowed to become more convex. Behind the suspensory ligament there is a sacculated canal, the spatiozonularis canal of Petit, which encircles the equator of the lens. It can be easily inflated through a fine blowpipe inserted under the suspensory ligament. No blood vessels penetrate the vitreous body, so that its nutrition must be carried on by vessels of the retina and the ciliary processes, situated upon its exterior. The crystalline lens, lens crystallina, the crystalline lens, enclosed in its capsule, is situated immediately behind the iris, in front of the vitreous body, and encircled by the ciliary processes, which slightly overlap its margin. The capsule of the lens, capsula lentis, is a transparent structureless membrane which closely surrounds the lens and is thicker in front than behind. It is brittle but highly elastic, and when ruptured the edges roll up with the outer surface innermost. It rests behind, in the hyaloid fossa in the forepart of the vitreous body. In front it is in contact with the free border of the iris, but recedes from it at the circumference, thus forming the posterior chamber of the eye. It is retained in its position chiefly by the suspensory ligament of the lens, already described. The lens is a transparent, biconvex body, the convexity of its anterior being less than that of its posterior surface. The central points of these surfaces are termed respectively the anterior and posterior poles. A line connecting the poles constitutes the axis of the lens, while the marginal circumference is termed the equator. Structure. The lens is made up of soft cortical substance and a firm central part, the nucleus. Faint lines, radii lentis, radiate from the poles to the equator. In the adult there may be 6 or more of these lines, but in the fetus they are only 3 in number, and diverge from each other at angles of 120 degrees. On the anterior surface one line ascends vertically, and the other 2 diverge downward. On the posterior surface one ray descends vertically, and the other 2 diverge upwards. They correspond with the free edges of an equal number of septa composed of an amorphous substance which dip into the substance of the lens. When the lens has been hardened, it is seen to consist of a series of concentrically arranged laminae, each of which is interrupted at the septa referred to. Each lamina is built up of a number of hexagonal, ribbon-like lens fibres, the edges of which are more or less serrated, the serrations fitting between those of neighbouring fibres, while the ends of the fibres come into apposition at the septa. The fibres run in a curved manner from the septa on the anterior surface to those on the posterior surface. No fibres pass from pole to pole. They are arranged in such a way that those which begin near the pole on one surface of the lens end near the peripheral extremity of the plane on the other, and vice versa. The fibres of the outer layers of the lens are nucleated, and together form a nuclear layer, most distinct towards the equator. The anterior surface of the lens is covered by a layer of transparent, columnar nucleated epithelium. At the equator the cells become elongated, and their gradual transition into lens fibres can be traced. In the fetus the lens is nearly spherical, and has a slightly reddish tint. It is soft and breaks down readily on the slightest pressure. A small branch from the arteria centralis retina runs forward, as already mentioned, through the vitreous body to the posterior part of the capsule of the lens, where its branches radiate and form a plexiform network, which covers the posterior surface of the capsule, and they are continuous around the margin of the capsule with the vessels of the pupillary membrane and with those of the iris. In the adult the lens is colourless, transparent, firm in texture, and devoid of vessels. In old age it becomes flattened on both surfaces, slightly opaque, of an amber tint, and increased in density. Vessels and nerves. The arteries of the bulb of the eye are the long, short, and anterior ciliary arteries, and the arteria centralis retina. They have already been described. The ciliary veins are seen on the outer surface of the choroid, and are named, from their arrangement, the vena vorticosi. They converge to 4 or 5 equidistant trunks, which pierce the sclera midway between the sclerocorneal junction and the porus opticus. Another set of veins accompanies the anterior ciliary arteries. All of these veins open into the ophthalmic veins. The ciliary nerves are derived from the nasociliary nerve and from the ciliary ganglion. End of section 52.